In this lesson, we're going to focus on users' roles security, one of the two sides of security. The other side is the one that we just covered, wire level security. The two can go together, but they can also be used independently. For now, in this overview, we're going to focus simply on users' role security. Later on, we'll have a chance to talk about how this connects with wire level security. So the working file you're looking at is called users roles overview.txt. So let me begin with the two phases of users roles security. The first phase, the required one, is called user authentication, and this little picture reviews what we've seen before. So let's suppose there's a client against our web service, but we want to secure that web service. What that means in effect is in order to get to the web service, the client has to identify itself, so it needs to provide an identity, but it also needs to provide a credential that vouches for that identity. Now, Java is very flexible here. We can secure the entire service, which basically means the whole WAR file. So I've depicted that with a URL that ends with my web service. But we could also, if we like, limit the security to part of the WAR file, in effect, to selected operations. So in this case, with the URL ending with mywebservice/special. So only those operations under special would be secured. Now, the second phase in users' role security, this is the optional phase. It typically occurs under the hood. This is role authorization. And if you're looking at REST-style services, it's easy to explain. Basically, this has to do with which CRUD operations are allowed for a particular identity. So, for example, I might hit a web service and be allowed to read information because that's the limit of my authorization. You might hit the same web service but be able to, for example, edit or even delete information because you have other authorization. Now, with respect to users' role security, we have seen the rather clever Amazon approach to this. Clever because it's so simple. Again, when you register with Amazon, you get an access ID. That's your identity. You also get a secret key. The secret key is not the credential itself. The secret key is used to generate a hash value that you send over the wire, and it's that hash value that acts as the credential. What Amazon does on the receiving end is it recomputes that hash value. If its computation matches yours, it's a go. Otherwise, you're denied access. Now, for programmers, in fact, for anybody who uses computing devices, this two-phase security process is familiar, although we don't always use these terms. So, for example, when you log into any device, a desktop machine, a handheld, whatever, you typically provide a username and then a password. The username obviously is the identity. The password then acts as the credential. Down here in about the middle, I just review basically the terms again. User authentication, role authorization. It's convenient to refer to these together simply as auth. So the first auth is the user authentication. The second auth is the role authorization. Now let's turn a bit to the programming side of things. So we want to divide the labor again between the service side and the client side. So on the service side, there are, at least in principle, two approaches you might take. You might do security at the application level. This is not a particularly good idea, doesn't scale, it's ad hoc, takes too much work. You basically wind up, when you go from an unsecured to a secured service, you wind up changing the code, or at least injecting new code into old code. A better way, so the preferred way, is to do what is known as container managed security. So, for example, if Tomcat's going to be our web server, or anything comparable to Tomcat, we want to turn the user's roles work over to Tomcat. That's basically the gist. Now, Tomcat provides all sorts of options for doing this. They're quite sophisticated, and we'll look at those a bit later. For now, I want to turn to the client side because the question becomes, how do we get the identity and the credential over to the server? So Tomcat out of the box does not support the Amazon approach. Instead, Tomcat is really looking for a username and a password, and so the client needs to get the username and the password in the incoming request in such a way that Tomcat can find it. So we turn again to HTTP. It has something called HTTP Basic, which is short for Basic Access Authentication, and it supports storing an identity together with a credential and an HTTP header element. The only catch is that this information has to be formatted in a particular way so that Tomcat is able to extract it. And we'll get into those details when we have a look at some code.